Flight 72 is suddenly in a dangerous nosedive. Captain Sullivan grabs the side stick to try to level his plane. It doesn't respond.
Once I pulled back on the stick and nothing happened, I'm thinking, okay, I'm not in control of this plane.
On October 7th, 2008, Qantas Flight 72, an Airbus A330-303 carrying 303 passengers and 12 crew members, departed Singapore's Changi Airport, heading to Perth, Australia.
Flight 72 departed from Singapore. The flight path covers almost 2,500 miles across the southern Indian Ocean to Perth, Australia.
It was a route the aircraft had flown countless times before, a routine 5-hour journey across the Indian Ocean. But what started as a normal flight quickly spiraled into a life-threatening ordeal. Mid-flight, the aircraft's primary flight computers began to malfunction, causing it to suddenly pitch downward in a terrifying nosedive. Passengers and crew were violently thrown against the ceiling, resulting in over 100 injuries, including spinal fractures and broken bones. Chaos and confusion spread through the cabin as the crew fought to regain control of the aircraft. This was a moment of sheer horror that would test the skill and composure of everyone on board. The terrifying sequence of events on Flight 72 was unlike anything the experienced crew had encountered before. Captain Kevin Sullivan, a former U.S. Navy Top Gun pilot, was no stranger to high-stress situations.
I do apologise. I'm sure you are aware we have a technical issue with our number 2 engine. We have dealt with the situation.
However, nothing could have prepared him for the sudden and catastrophic failures that threatened to plunge the aircraft into the ocean below. In those critical moments, the survival of everyone on board depended on his ability to diagnose and respond to a rapidly deteriorating situation, one that no training manual could fully anticipate. To fully understand the gravity of the situation, it is important to look at the technological complexity of the Airbus A330. This sophisticated aircraft relies on multiple automated systems to assist pilots. But when these systems malfunction, they can quickly become a pilot's worst nightmare. The series of failures that occurred on Flight 72 revealed vulnerabilities in modern fly-by-wire systems and the potential dangers posed by erroneous sensor data. In the aftermath of the incident, aviation experts and safety regulators conducted an extensive investigation to determine what went wrong. Their findings led to critical changes in the way aircraft manufacturers design and test automated flight control systems, ensuring such failures are less likely to occur in the future. Qantas Flight 72 stands as a stark reminder of the delicate balance between human skill and technological reliance in modern aviation. This harrowing story is not just about a flight gone wrong, it's a tale of courage, resilience, and the unwavering determination of a flight crew that refused to give up. If you're fascinated by real-life aviation incidents and want to hear more incredible survival stories, make sure to subscribe for more gripping content. The routine flight that turned deadly Qantas. Flight 72's journey began like any other. The Airbus A330, delivered to Qantas in 2003, was a well-maintained aircraft designed for long-haul flights with state-of-the-art fly-by-wire controls. Captain Kevin Sullivan, an experienced aviator with over 13,000 flight hours, was in command alongside First Officer Peter Lippett and Second Officer Ross Hales.
Captain Kevin Sullivan is a former Top Gun fighter pilot with the U.S. Navy. Ross Hales is the second officer. First Officer Peter Lippett is the next pilot scheduled to go on break.
The flight was scheduled to depart from Singapore's Changi Airport and arrive in Perth, covering a distance of over 3,900 kilometers across the Indian Ocean. At 1:25 p.m. local time, Flight 72 pushed back from the gate and taxied to the runway. The pilots performed their routine pre-flight checks, and once cleared for takeoff, the engines roared to life, propelling the aircraft into the skies above Singapore. The takeoff was smooth, and the crew engaged the autopilot, allowing them to settle into cruise mode. The flight was progressing normally when, at approximately 3:28 p.m., the first sign of trouble appeared. A master caution alert was illuminated in the cockpit, indicating a fault with the Air Data Inertial Reference Unit, ADIRU. These units are crucial for providing essential flight data, including altitude, speed, and navigation inputs. The crew followed standard procedures to address the issue, temporarily resolving the fault and continuing their journey. However, true to Captain Sullivan's reputation as the magnet for bad luck, the flight's problems were far from over. As they crossed Indonesian airspace and neared the Australian coastline, a second warning appeared on the Electronic Centralized Aircraft Monitor, ECAM. The system displayed inconsistent airspeed and altitude readings, confusing the pilots and raising concerns about the reliability of their instruments. The flight crew quickly realized they were facing a potentially serious situation. Modern aircraft rely heavily on automated systems, but when these systems begin to malfunction, pilots must rely on their training and instincts to manage the situation manually. Captain Sullivan decided to disengage the autopilot and hand-fly the aircraft to ensure stability. Passengers remained unaware of the developing situation, enjoying their meals and in-flight entertainment. In the cockpit, however, tension was mounting as the pilots worked through checklists and attempted to diagnose the faulty readings. First Officer Lipet commented with a nervous laugh, "Here we go, Kev. Your luck strikes again." Despite the challenges, the crew maintained control, ensuring the aircraft stayed on course. But what they didn't know was that the worst was yet to come. The faulty air data system would soon trigger an unprecedented series of events that would push the Airbus A330 and its crew to the brink of disaster. At 37,000 feet, Flight 72 was cruising smoothly when, without warning, the autopilot suddenly disconnected. Alarms blared in the cockpit, and the master warning light illuminated. Within moments, the aircraft violently pitched down, sending passengers and crew flying toward the ceiling. The negative G-forces created chaos, with loose objects and unrestrained passengers slamming into overhead compartments and fixtures. Captain Sullivan, who had just returned to the cockpit, grabbed the side stick and pulled back forcefully, trying to level the aircraft. However, the plane's fly-by-wire system resisted his inputs, interpreting them as unnecessary. The faulty air data unit was feeding erroneous angle of attack readings to the flight control computers, causing the system to mistakenly believe the aircraft was stalling and triggering automatic nose-down commands. As the aircraft descended at an alarming rate, the first officer attempted to silence the alarms and analyze the ECAM messages. The barrage of warnings made it nearly impossible to focus on the root cause of the malfunction. With no reliable airspeed or altitude readings, Captain Sullivan had to rely on instinct and experience to stabilize the aircraft manually. Just as the crew managed to regain some control, the aircraft pitched down again in a second violent dive. The sudden descent resulted in more injuries in the cabin, with several passengers sustaining fractures and concussions. Flight attendants scrambled to secure passengers and assist the injured while bracing for further instability. In the cockpit, the crew faced a dire situation: repeated automatic nose-down commands, unreliable flight data, and an aircraft that refused to behave as expected. With limited options, Captain Sullivan disengaged the autothrust and switched to manual flight control.
ECAM's showing a lot of errors.
Stall.
Overspeed warning.
Stall.
How can we be in a stall and overspeed at the same time?
Stall.
We can't. Airspeed's unreliable. Disconnecting autopilot.
relying on standby instruments to guide them out of danger. The struggle between man and machine was far from over. As the aircraft continued to pitch down violently, Captain Sullivan and his crew were locked in a battle against the plane's automated systems. Every attempt to pull up was met with resistance as the faulty flight control computer continued to override manual inputs. Sullivan's extensive military training kicked in as he methodically worked through his options, instructing the first officer to monitor standby instruments while manually adjusting the thrust. Despite their efforts, the aircraft pitched down again, forcing the crew to counteract the descent with careful, deliberate control inputs. Passengers were screaming in terror, and cabin crew worked tirelessly to assist the injured while ensuring everyone remained seated and strapped in. As the aircraft continued to struggle with the repeated automatic nose-down commands, the crew realized they could not trust the flight control systems. Captain Sullivan and his team were left with no choice but to manually fly the aircraft using standby instruments, which provided limited but reliable data. With the situation deteriorating rapidly and injuries mounting among passengers, the decision was made to divert to Learmonth Airport, a remote airstrip on the Western Australian coast. Making the diversion decision was not easy. Learmonth was a military airfield with limited facilities, but it was the closest suitable landing site within range. The crew weighed their options carefully, considering fuel reserves, passenger safety, and the potential risks of another sudden dive. At 4:40 p.m., Captain Sullivan declared a pan-pan emergency to air traffic control, signaling that the flight was in distress but not in immediate danger. However, as more passengers were reported injured and the flight computers continued to malfunction, the captain upgraded the call to a full Mayday, requesting priority landing clearance at Learmonth. With the diversion set, the crew focused on preparing the aircraft for descent and landing. Flight attendants worked tirelessly to secure the cabin, assisting injured passengers and ensuring everyone was properly strapped in. In the cockpit, Captain Sullivan and his team meticulously calculated the approach, knowing they would have to manually control every aspect of the landing without the aid of automated systems. Despite the chaos, the pilots executed a series of cautious maneuvers to bring the aircraft into a stable descent. Challenging, but Sullivan relied on his extensive experience to guide the aircraft visually. As Flight 72 approached Learmonth, the tension in the cabin was palpable. Passengers braced themselves for what was expected to be a difficult landing. In the final moments, the crew manually lowered the landing gear and flaps, ensuring a controlled approach to the runway. At 5:32 p.m., the aircraft touched down safely, rolling to a stop as emergency services rushed to the scene. The relief among the passengers and crew was overwhelming, but the ordeal was far from over. Medical teams boarded the plane to assess and treat the injured, while aviation authorities began their initial investigation into the incident. The decision to divert to Learmonth proved to be a life-saving choice. Despite the challenging circumstances, the crew's swift actions and expertise ensured that every passenger survived, making Flight 72 one of the most remarkable emergency landings in aviation history. As Flight 72 descended toward Learmonth Airport, the situation remained precarious. The crew meticulously monitored every aspect of the approach, fully aware that any sudden system failure could spell disaster. Captain Sullivan and his team had switched to manual flight control, relying on their training and experience to guide the plane safely to the ground. As they neared the runway, the crew manually extended the landing gear and flaps, carefully adjusting the descent rate to avoid triggering another unexpected pitch-down event. The passengers sat in silence, gripping their seats as the aircraft approached the barren, remote airstrip surrounded by the vast Australian outback. The final moments before touchdown were filled with tension. Without the assistance of automation, Captain Sullivan had to gauge the plane's position visually and control the descent precisely. At 5:32 p.m., the wheels finally made contact with the runway, sending a collective sigh of relief through the cabin. Despite the complexity of the situation, the aircraft touched down smoothly and rolled to a stop, with emergency crews rushing to meet it. The cabin erupted with cheers and tears as passengers realized they had survived the terrifying ordeal. However, their relief was short-lived as they saw medical personnel quickly board the aircraft to attend to the injured. More than 100 passengers and crew members required immediate medical attention, with several suffering from severe injuries, including spinal fractures and head trauma. With the aircraft now safely on the ground, the focus shifted to stabilizing the injured and assessing the aircraft's condition. The flight crew coordinated with ground personnel to ensure that those in critical condition were evacuated first. Helicopters were dispatched to transport the most seriously injured passengers to hospitals in Perth for urgent medical care. Meanwhile, aviation experts from Qantas and Australian transport authorities began their initial investigation into the incident. The priority was to secure the flight data recorders and gather crucial information about what had gone wrong at 37,000 feet. Despite the harrowing experience, the successful emergency landing at Learmonth was a testament to the crew's extraordinary skill and composure under pressure. Captain Sullivan's extensive military background and rigorous airline training played a crucial role in ensuring the safety of everyone on board. In the days that followed, the passengers and crew of Flight 72 began to process the traumatic experience they had endured. Many credited the quick actions of the flight crew and the calm professionalism of the cabin staff for preventing what could have been a catastrophic disaster. The incident left a lasting impact on those involved, and it would go on to influence changes in airline safety protocols and training procedures for future flights. Though Flight 72's journey did not end in tragedy, it served as a chilling reminder of the unpredictable nature of air travel and the critical importance of human intervention in the face of technological failures. Once the aircraft was safely on the ground, investigators from the Australian Transport Safety Bureau, ATSB, and Airbus specialists began analyzing the incident. The immediate priority was to secure the flight data recorder and cockpit voice recorder, which contained crucial information about the series of failures that occurred at 37,000 feet. Preliminary findings indicated that one of the aircraft's 3 Air Data Inertial Reference Units, ADIRUS, had malfunctioned, sending erroneous data to the flight control computers. This faulty data caused the aircraft to receive conflicting signals about its airspeed and altitude, triggering the aggressive nose-down commands that repeatedly plunged the plane toward the ocean. Investigators determined that the failure was linked to a rare software anomaly within the ADIRU system. Further analysis revealed that the aircraft's flight control computers, designed with multiple layers of redundancy, were unable to override the faulty ADIRU data, which resulted in automatic pitch-down responses. This raised significant concerns about the reliance on automated systems and prompted Airbus to issue software updates and operational guidance to airlines worldwide. In the weeks following the incident, Qantas and Airbus worked closely with aviation authorities to implement additional safety measures. Changes included improved pilot training programs focusing on handling unreliable airspeed indications and unexpected flight control system failures. Airbus also introduced new protocols to help flight crews recognize and respond more effectively to ADIRU malfunctions. For Captain Sullivan and his crew, the aftermath of the incident was emotionally and professionally challenging. The psychological toll of the near disaster was immense, with several crew members and passengers requiring ongoing counseling to process the traumatic experience. Captain Sullivan, deeply affected by the ordeal, later retired from commercial flying and became an advocate for aviation safety, sharing his experience to help improve industry standards. Passengers, too, struggled to come to terms with the terrifying event. Many expressed gratitude for the crew's professionalism and the calm handling of the emergency, while others pursued legal action against Airbus and Qantas, citing physical and emotional trauma. The legacy of Qantas Flight 72 endures as a case study in aviation safety, emphasizing the critical need for vigilance, human expertise, and continuous improvements in automated flight systems. The lessons learned from this incident continue to shape the way airlines train their pilots and maintain their aircraft, ensuring that such a harrowing event is less likely to occur in the future. The harrowing experience of Qantas. Flight 72 serves as a powerful lesson in the complexities of modern aviation and the critical role of human expertise in times of crisis. Despite the highly automated nature of contemporary aircraft, this incident highlighted the importance of pilot intervention and quick decision-making in mitigating disaster. The swift and calculated actions of Captain Sullivan and his crew ultimately prevented a catastrophe, showcasing their exceptional training and resilience. The incident led to significant changes in aviation safety protocols, with regulators and manufacturers implementing improvements to prevent similar failures. Airlines worldwide adopted new training programs focused on recognizing and responding to unexpected system malfunctions, reinforcing the need for constant vigilance and adaptability in the cockpit. For the passengers and crew, the memory of Flight 72 remains a defining moment, one that underscored the fragility of life at 37,000 feet. While the aircraft landed safely, the emotional and physical scars endured by those on board serve as a lasting reminder of the challenges and risks inherent in air travel. Qantas Flight 72 stands as a testament to the resilience of the human spirit and the unwavering commitment of aviation professionals to ensuring passenger safety. It is a story of survival, perseverance, and the relentless pursuit of improving air travel for all. If you found this story captivating, be sure to subscribe and stay tuned for more real-life aviation incidents and survival stories that highlight the bravery and skill of those who navigate the skies every day.